Editing. Hello everyone, myself Vishal Dobada. I am from JSPM NTC. This is our team Blackspanner 2.0. We are here to express something about our card. This is according to rule book. This is our card design CAD model. Team structure. There are 25 members in our team. One is captain, vice captain, 5 members for design and analysis, 5 for steering system, 5 for brake system, and 3 for documentation. According to rule book, our cart has some basic specifications. Wheelbase having this wheelbase 41 inch and the track width having front track width 34.5, rear track width 36.5 inches. We use a 125cc engine having developing maximum torque 11 Newton meter and the maximum power 11 bhp. Steering geometry is the Ackermann's geometry is used. Braking system is hydraulic and the type of transmission is chain drive. Vehicle cart having the mass 160 kg. Material used is AISI 1018. Ground clearance is 1.7 inches. We are tested chassis under the ANSYS. There are 3 forces are applied. One is front impact, rear impact, and side impact. In front impact, stress is applied on the front side of the car. There stress is shown in the green color and the deflection is in red color. In side impact, 3G force is applied. Force is applied in the side of the chassis, one side of the chassis. In this, stress is shown in the green color and the deflection is in the red color. In rear impact, stress is applied on the rear side of the chassis. This is also 4G load. Stress is shown in the green color and the deflection is in red color.
Myself Vishal Borade. Now I am going to explain the ergonomics considerations in the vehicle and the safety of our go-kart. We have using a detachable steering which is having 30 cm diameter, and we have taken the weight and the driver weight of the driver and the height of the cart. The ergonomics are taken the spacious cockpit, sufficient leg room, and which the main motto is the comfort of the driver for the driving of the go-kart. And also external safety we have taken like fire extinguishers, and for the main safety of the driver we are using a driver suit which is contains helmets, shoes, single layer driver suit, and etc. And main for the safety from the go-kart we have uses kill switches. We are basically using 3 kill switches. One is near the steering, second one is near the seat, and third one is near the brake pedal. When the brake is failed, the kill switch near the brakes can turn off the car. This is the ergonomics of our go-kart. The main motto of the ergonomics is the driver comfort and the people having a lower chance of the injury. And this is the chassis structure of our go-kart according to ergonomics. For the go-kart steering mechanism, we are using a totally 100% Ackermann geometry. The main goal of the steering is to have a steering radius near about the 3.5 meter, or the less than have a 100% Ackermann geometry. We have calculated the following values, and these are some values of our steering mechanisms, which is having inner turning angle 44.44 degree, outer turning angle is 28.24 degree, and we have taken the caster angle which is near about the 6 degree, and we don't change the camber angle which is 0 degree, and the kingpin inclination angle is near about the 7 to 8 degree. For the safety we have taken the 7 degree angle, turning radius. From these values, we have got a turning radius which is near about 1.5 meter, and we have using a two tie rods in the steering mechanism. The two different tie rods actually, and the left tie rod having a 350 mm length, and the right tie rod have a 340 mm length, and the steering wheel column or steering wheel or column diameter of the steering is 14 inches.
Hello, myself Vipul Chaudhary, and I am presenting braking system. In designing a braking system, first the main aim of braking system is to stop the vehicle. Now we use the single cylinder double piston type of braking system. We use stopping vehicle to stop the vehicle. We use master cylinder in the front near the brake pedal and rear single disc near the rear axle. Now the braking disc used in this system is Yamaha, and the master cylinder used is Bajaj Pulsar 220. Now we assume the manually applied load as a 250 Newton. According to our calculation, we calculate for single piston as well as for double piston. As our calculation is done, the single piston give more distance for stopping as compared to double piston. So we doesn't take single piston in consideration. So we find or select the double piston for the remaining use. Next. Now I explain the engine and transmission. First of all, according to the rule, we can consider the three types of engine in order to fulfill our requirement. We use Honda Stunner engine, Splendor engine, and Discover engine. In that, we can select the Stunner engine, which is having high power transmission as well as high torque. According to the specification, it having displacement 124.7 cc, just like it is 125 cc, having maximum power 11 bhp at higher speed 8000 rpm, having maximum torque 11 Newton meter, having lower torque 6500 rpm. Now we use transmission system is manually for power transmission. Now according to this system, the engine which we use is which is having 101 km per hour speed. But according to our go-kart, we can design or set the 60 km per hour for the speed for the vehicle. Next. For designing of shaft, according to ASME, we design the shaft. Under this, we can select here 90 for the shaft material. Now, according to the design data book, we can select L stress, ultimate stress. Now, we can assume the weight of vehicle as a 160 kg, 100 kg for chassis, engine, and other parts of a vehicle, and 60 kg for the driver. Now, according to the weight distribution, in that rear wheel having 60% of weight and front wheel has having 40% of weight. According to our braking design, we can find out the braking torque from that, and according to this, we can find here braking moment, and then use of the ASME equation, we can find out the diameter of the shaft. The diameter of shaft is 29.6 mm, but according to our consideration, we can take higher value as a round of 30 mm. Next.
Hello everyone, I'm Sagar Pochre. Now I'm going to introduce or inform about total costing of our go-kart. The total cost of our go-kart is 64,220 rupees. The main components of our costing department is wheel, tire, chassis, and the frame. This is the design validation plan. In design validation plan, we consider the different components like FEM analysis, powertrain, steering, braking, tire, and electrical system. In FEM analysis, we accept the different criteria like factor of safety is 3, front impact is 3, side impact is 2, and rear impact is 2.5. By hand calculation and CA analysis, we got the factor of safety is 3. Powertrain, for the maximum acceleration and safety of driver, we use the powertrain which is operated manually. And steering system, we use the 7 degree of grip play which is comfortable to the driver. Braking system, For the maximum stopping distance, which is having a 4.73 meter, we use the single cylinder double piston brake. In tire, we use the standard go-kart tires. In electrical system, we use the standard Honda Stunner wire harness. This is our DFMH chart, in which having a maximum RPM, that is risk priority number, is brake, and the real priority number, which is less for the engine. This is our total process chart from the introduction of the new team member up to the testing. Thank you.